I think let's wait for a minute or two more so that more people may join in. Yeah, just a minute more so that we can have more people join us. All right, let's begin then. Greetings to everyone who has joined us today for the 5th session of Association of Quaternary Researchers ECR web series, both via Google Meet and our YouTube channel. I'm Ayush, one of the ECR members of the association, and I welcome you all today. We've had a fantastic run so far, and in a last talk, which was delivered by Dr. Parth Chauhan from IISER Mohali, it attracted an audience of over 250 people and some excellent feedback. So thank you all for your wholehearted response. And some common housekeeping rules before we begin today. Please make sure that your camera and microphone and you don't accidentally turn these on. Second, please also be careful to not share your screen, which causes unnecessary interruption. And we do have time for questions and discussions in the end. And to streamline the process, it would be nice if you could type in your questions in the comment box. Our ECR team will collate your questions and queries from both Google Meet chat box and YouTube comment section for the speaker to answer after the talk. Before we begin today, I would invite Dr. Vinita Fartiyal to pay tribute to Professor K.S. Waldia on the behalf of the Association of Quaternary Researchers.
Yeah, hello. Am I audible?
Yeah, yes, you are, ma'am.
Okay, good afternoon, everybody. As we all know that on the 29th of September, India lost a distinguished geoscientist, Bhashan, Padmashri, Professor K.S. Waldia. The Association of Quaternary Researchers family pays tribute to this distinguished scientist, an academician, author, and active environmentalist, a teacher par excellence, Professor Waldia. We all know that Professor Waldia specialized in tectonics with special reference to active faults and environmental geology. Although his work covered almost the entire geological timescale, right from Precambrian to Quaternary, he worked on stromatolites and he wrote a book on neotectonics too. His fundamental studies and research on the Uttarakhand Himalayas serves as a template and a guide for interpreting the structural architecture of the entire Himalayan range. He was a man of great wisdom, very hardworking. Whenever we would go to visit him, there would be a heap of research papers, the latest research papers. He had a pencil in his hand and he used to read it line by line. And I'm talking about when he was in his 70s and in his 80s, like till his last, he was doing this. His love for rocks, his love for books was immense. His passion for teaching was apparent in the order with which he gave his lectures. He was involved in several outreach programs in the hills, and whether it was something very simple or very complex, he showed the same enthusiasm when he was explaining things, and that is the same zeal that he radiated every time he taught or gave a public lecture. He was certainly a teacher par excellence, and at the same time, he was a curious student, and which he remained all his life. And this is a very rare combination, a student and always a student and always a guru. I recall the field trip in Ladakh, Trans-Himalayas in 2016. And the day we were there, it was the acclimatization day. And I remember that he found that he hadn't bought his notebook. And he was so restless. And he went to the Leyland book depot in the town. And till, he was so restless that till he got it. And then he started his acclimatization. And in those 10 days we were there, he wrote filled about 3 notebooks. So he was a very keen observer, and at that age he must have been 81. Though he used to say it's my certificate age, and I'm like 84 now. So just imagine. What a man. Very soft-hearted, very jovial. And in spite of his hard hearing, which, when he was born in Burma, and during that time, the Second World War, the bomb blast, he lost his hearing. And then he always had a hearing aid. And then he with his grandfather, they shifted to the Kumaon Hills, stayed there in Pithoragarh. And there also, at a very early age, he got typhoid. And because of that typhoid, he lost... his eyesight also became very weak. But this hard hearing, this weak eyesight were never an obstacle to achieve the highest honors of India, that is the Padma Awards, which he received. Wherever he was placed, whether it was Lucknow University, Rajasthan University, Wadia Institute of Himalayan Geology, Kumaon University, or JNC Bangalore, he never stopped researching. He never stopped writing books. He never stopped popularizing science. He wrote over 110 research papers. He authored 20 books. He penned several dozens of articles in Hindi. He was a great orator, and the command over both Hindi and English were superb. Some of his books are The Geology of Kumaon Lesser Himalayas, 1980, Aspects of Tectonics, Focus on South Central Asia, 1984, Environmental Geology in 1987. He wrote Dynamic Himalaya in 1998, Saraswati, the river that disappeared in 2002, Geology, Environment and Society in 2005, The Making of Himalaya, Geodynamic Evolution in 2010, and many more. He also wrote his autobiography, The Patharili Raho Par, that is on the rocky roads, and it's a worth reading book about his journey of 80 years in that. Throughout his life, he had been conferred with several awards ever since 1954, when he got the Chancellor's Medal. Then he had the Shanti Swarup Bhattnagar Prize in 1976, the National Mineral Award in 1993, the N. Wadia Medal in 1995, National Mineral Award of Excellence in 1997, Padmashri in 2007, GM Modi Award for Science and Environment in 2012, and Padma Bhushan in 2015. And I'm very sure if he had lived a little long, he would have had the Padma Vibhushan also. He was a fellow of all the societies, National Society Academies in India, and also the Third World Academy of Sciences, and also an honorary fellow of Geological Society of America and Geological Society of Nepal. He served as a council member in INSA also, and also in the Science and Advisory Committee of the Prime Minister Office, where he influenced the national policy on science and environment too. One simple glance on his allocates in the Wikipedia will show his achievements and contributions. But in spite of all those, you would find him a very simple man, very down to earth. This shows his greatness because no matter how important a person he was and about his achievements and contributions he had, he always had time to talk to you. He always had time to talk to students, people, anyone and everyone. A great son of the nation, a great geoscientist has left us, and this void will be very hard to fill. On behalf of the AOQR and all the members, honorary members, and this quaternary family, and on my own, we pray for his peaceful afterlife and our deepest condolence for the entire family, his wife, Mrs. Indra Waldia, and to his family and friends to bear his immense loss. I was blessed to have him as my teacher, and several of the batches of students in those days were inclined towards geology because only of this one man, Professor K.S. Waldia. He was a superhero, and he always will be. With these words, we all pray for the departed soul. We always will miss him, of course. Thank you. Thank you, Ayush. Over to you.
Thank you, Dr. Parthial. Back to the talk. We're very pleased to have Dr. Gayatri Kathayat, who will be speaking on the 4.2Ka event in the Indian subcontinent. And I'll give you a little introduction about Gayatri. She's an associate professor at the Institute of Global Environmental Changes, Xi'an Jiaotong University in Shaanxi, China. For her PhD, she investigated the variability in the Indian summer monsoon on various timescales, and she earned her doctorate from Xi'an in 2016. Her core expertise is in the field of monsoon reconstruction using cave speleothem on a wide range of timescale. Her range of excellent papers published in leading journals like Science and Nature clearly demonstrate how passionate she is about all things related to the monsoon. She's delivered several lectures and talks in different parts of the world, including the States, Vietnam, Madagascar, to name a few. And AOQR is really excited to have her online today. So on the behalf of the entire team, I welcome you, Gayatri, and over to you now.
Thank you, Ayush. Thank you so much for such a lovely introduction. I hope I won't make people bored today. Very good afternoon to everybody. And I won't take much of the time and just start my presentation. Okay. I'm a paleoclimate person, and that's my key expertise, one of my key expertise. Paleoclimate is a very important part for the modern society. We contribute a lot, whether we study the long-term changes in the climate system, or we are talking about the modern changes. So if you talk about the long-term climate history, those reconstructions help us to understand that how far the strong natural forcing changing boundary conditions can reorganize the environmental system. And then when we come on to the human timescales, it is very important because when we characterize the extreme climatic event, we prepare a kind of a roadmap for any developing nation to see how the future environment will look like. So in that context, today I'm picking up one of the very extreme climatic event, which is very popularly well known. It has been studied much now over the past 2 decades almost. We have more than 200 plus proxy records to understand the 4.2K event, or I should say that it has been reported from these many sites. And it is associated with the demise of a lot of ancient historical cultures, societies. So today I'll take you solely towards the Indian subcontinent, how this event looked like over the Indian monsoon domain. So the focus of my talk is to pick the band of time from 3.9 to 4.2 and understand the variability of Indian summer monsoon during this window of time, this time frame. And what I'm doing for that is I'm going through all the proxy record available so far and taking them back to last 7,000 years in this long time framework. And then I'm just trying to see the shift in the monsoon from its mean or from the variance or from both the aspects to see how the climate has been deviated during this time window. Before I move forward, I start with a very cautionary note here, which is that paleoclimate business is basically the real estate business. What really matters here is the location. Location is the key. Considering that everything else being equal, all the proxy sites are not optimally located in such a sense that we can have the real reconstruction of the monsoon. Therefore, all the proxy records, they are not equal. Hopefully, towards the end of my presentation, this statement could be more clear and better understood, or I should say better explained. So I start with what we are seeing on the spatial map on the background is the precipitation mean of June, July, August. So what we see here is we have...
excuse me, Gayatri, your screen is not presented, not yet.
Really?
Yeah, you have to present your screen.
I'm so sorry.
I thought you were giving us an introduction.
Okay.
Please share your screen.
Let me start it again. Is that fine now?
It's coming. Just
Oh,
present
I'm
your.
sorry.
Yeah, it's okay.
Okay, please let me know if I'm not audible or if something is missing in the
Yes,
middle.
you are absolutely clear.
Okay, so I'm just starting the first map here, so it's not something we miss too much. Is that fine now?
Yes.
Okay, great, excellent. So what I'm showing here in this special pattern here is I'm just giving a brief introduction about the Indian summer monsoon. That is, we have the monsoon season from June to September. So what you're seeing is the spatial pattern of mean June, July, August, September precipitation using the TRIM dataset. What we see in the focus here on this map is we are seeing the maximum precipitation is over Bay of Bengal, the Western Ghats, and the equatorial Indian Ocean. Then what we see is that we have a steep gradient of precipitation from Bay of Bengal to Northwest India. How strong the Indian summer monsoon is going to be, that decides the limit, the northwestern limit of the monsoon, how far it can penetrate. If we have really good monsoon, the Indian monsoon can penetrate far towards Pakistan. And to understand the strength of Indian summer monsoon, basically it is expressed in terms of all Indian rainfall index. And this index is basically the area minus weighted June, July, August rainfall over the Indian subcontinent. So when we now look into these sites where we have maximum precipitation, we see that the correlation between the summer monsoon, all Indian summer monsoon rainfall index, and these sites is statistically insignificant or kind of weak. So looking more deep, if we go into the continent, we see the location from northern India and central India. We see that these sites are potentially more robust for the paleo precipitation reconstruction. They are capable of explaining at least 30% of the variance of the Indian summer monsoon variability. So this is a very brief introduction about site relation to precipitation. I have been working more into the dynamical part, which calls for a presentation on its own, and that paper is on its way. So soon we will have more modified version of understanding proxy from the Indian subcontinent. So here we are seeing is now the wind speed. So we see that we have the low-level jet, the southwest monsoon, which enters into the Indian continent. And the main moisture corridor is from the Arabian Sea. This Arabian Sea moisture enters to the core Indian monsoon zone, which enters to Bay of Bengal. And then from Bay of Bengal, it is recurvated towards the northwest part of India, which is the Bay of Bengal branch, basically, and causing a strong monsoon circulation over the core monsoon region. So I have not highlighted the core monsoon region here, but it is a region which is somewhere around 18 degrees of north to 28 and 80 to 65 of the Indian subcontinent. So what we see finally here is that if we are very close to the Arabian Sea side could be potentially very useful if we want to understand the monsoon circulation strength for the past. So it can help us to reconstruct the monsoon circulation through wind speed. So this is the basic structure, how we see the wind pattern of the Indian monsoon circulation and the basic idea of precipitation. Now looking into the proxy records in more details. So we have a lot of marine records which are to the coastal side of India. And these records, they are basically recording the especially integrated precipitation amount. If you see that black box, and then we go to the core of Bay of Bengal, we can see that these sites, they are helping us to understand the changes which is taking place over the core monsoon region. But unfortunately, the resolution and the dating uncertainty of these sites or these records is not sufficient for us to evaluate the 4.2 event. So we are taking the proxy from the western coast of India, which is the Indus Delta record. for our today's synthesis. Then white stars and the yellow stars shows you the location of lake records available so far. Many of these records still, they lack the sufficient resolution, and the dating uncertainty is really high. So among these records, I'm selecting 3 of the main records, which are basically located, highlighted by the circles, and they are located in northern India, core monsoon zone, that is central India, and the higher Himalayas, which is coming from Nepal, that is Lake Rara. Then the third proxy is the marine records, which are talking about the upwelling, the productivity. Again, unfortunately, we don't have the sufficient resolution for today's synthesis. So I'm leaving these records behind. And we have another proxy is the speleothem records. So far we have really high resolution speleothem records from 3 sites, and that is Sahiya Cave, which is sitting, and then we have Mamluk Cave records, which are replicated, already published by Berkelhammer in 2012, and we have another record in 2018. So these are now the selective sites. On the left panel, we can see the stack. First basic instance, all the stack record together, more or less all of them, they are similar, and they do show the weakening in the monsoon around 4.2. So the next step is I'm detrending this data set and then evaluating each record one by one on its own. Let's start from Kotladhar Lake. So you can see the black line tells you the transit point, which is around 4.1. And we can see there is a prominent shift from wet phase or the pluvial phase to the drier conditions. And we can see that this drying trend has been lasted all through the record from 4.1 onwards. So last 1,000 years of weakening. So now looking into the lake record from Lake Rara, we do see a lot of variability there. And around this time period of 3.9 to 4.2, we see a multi-centennial drought of 700 years approximately. Technically, if we look into the Indian summer monsoon modern observation data, the core idea about the Indian monsoon is that by Professor Webster in 2003, and even which is believed by the meteorological department, that the monsoon cannot deviate from its mean state for more than 2 to 3 years. So in a simple word, or the common language, we can say that if you see that there was a weak monsoon this year or next year, then in the 3rd year, you're going to have a good monsoon back again. So here in this proxy record, we are seeing a weakening of monsoon for last 700 years, that is multi-centennial week. How feasible it is? That raises the question right there. So coming into the Lonar Lake, we have a gradual transition towards the drier conditions, and which initiates around 4.5, and then it goes along to last 4,000 years. Okay, looking into the Indus Delta. If we look onto the detrended data from Indus Delta, we see there is a lot of variability up and down. We have pluvial, we have drought. So if we see in this context, in long context, we don't see that 3.9 or to 4.2, this band is really special. It doesn't stand out unique. So it's still, seeing in these terms, it's very hard to say that we had the 4.2 or we do not have the 4.2. It's still a question remains. Now looking into KMA record. So we see a prominent shift from 1 standard deviation in the speleothem record around 4.2, which is going back to the pluvial conditions. Looking into Sahiya record then, and if you focus onto the time window from 3.9 to 4.2, what we see the most striking is it's mostly pluvial rather than the severe drier conditions. So drying in Sahiya record almost starts after 3.9. Going into the summary, we do see a drying, but we see continuous drying in many of the proxy records. We do see a event of 160 years on Mamluk record. Then again, if we come to the Sahia cave, we have the opposite relationship. So still, from all these proxy records, what we conclusively can say is nothing about 4.2, whether it was there or whether it was not there. So I'll get back to this this slide again towards the end, this question again towards the end of my talk. So from here, I'm taking you now specifically to the Mamluk side, where you have this stratotype from KMA, speleothem sample from Mamluk record. The golden spike is right there, where you see the arrow. So we all know it's a very famous, this record is coming from Bulker Hammer in 2012 from Mamluk Cave. And there the yellow band shows the drawing and marking the 4.2 event right there. And the black horizontal line shows you the age uncertainty, the uranium series dating. So by the way, I would like to mention here that this sample was dated by my group in 2012. That time I was not a part of these studies and of course, not even the part of this laboratory. So, but now I'm working with them closely. So I have this chance to understand how far this record is believable or not. Can we understand this record in light of new additional record from Northeast India or not? So here is a picture of Mamluk Caves speleothem. And many of you might have seen it in Birbal Sahni Institute, Lucknow. So what you see here is that there is a white boundary layer on the top. The sample is becoming more tapered towards its top, which is not a good sign when you talk about speleothem. So speleothem community, when we see the stalagmite in such conditions, it's really very difficult for us to stand robustly and say something, the reliability of the data, the delta 18 from this kind of sample. And this is, I think, one of the reasons that the authors of this paper, the main authors of this paper, they really did not talk much about the 4.2. They did not really emphasize on the event tracked in this sample. So now I have placed the delta 18 over the picture of the sample. What you see here is the red box, which is highlighting the time and the location in the sample where actually the 4.2 event has been captured. For people, those who are very new to speleothem, I have a point here to add on. In stalagmite or in the cave system, it's very easy for the system to make the delta 18 get more positive. Certain things, it's not only the climate, but the cave system itself can lead the delta 18 become more positive. So that this could be one of the possibilities that you really see the extreme values around this time period in the entire record over the last 8,000 years. So I'm zooming into this red box here. And what you see here, you're seeing here there is a top date at 3.6. And then another date is at 4.1. And this is the box right there where you have this prominent 4.2K event. And this could be anything. There is a severe dissolution on the top of this sample that what you really see because it has become more tapered from the top. And this dissolution could be because of the moon milk. People, those who have not visited Mamluk Cave. So I would like to add here that Mamluk Cave has a lot of this moon milk, and this could be one of because of the mining activity. Many people have dated this moon milk timing on this cave in different speleothems. So this started around, mostly the date falls around 1950, which is very close to the timing when the mining activity in this region have been started. So this could be one of the possibilities that the delta 18 signal have been somehow diluted or changed, potentially altered because of this tapering feature on the top this speleothem is holding. So to understand how the 4.2 event is looking and to understand the robustness of KMA record, we replicated this time interval from another speleothem from the same cave. And you can see we have replication data set here, 2 speleothem sample going back straight from 3.5 to 4.5. So what's the speciality of this sample? Speciality is that it has a very high uranium concentration. The average uncertainty is around 11 years. We have an average dating resolution of 40 years, and the delta weighting resolution is almost seasonal. So in speleothem, age model is very, very important. It's really, really important. And it has to be unto a serious concern. So this is one of the reasons that we have used multiple age models to understand the actual age model, what we are using for the interpretation is robust or not. Because speleothems are not the proxies which are growing continuously. You can really have sometimes fast growth rate, you can have slow growth rate, you can have a hiatus, which is very hard to identify because of lack of dating. Because even if the hiatus is really for a very short duration, let's say for 10 years or so it's not that easy to track down. So ultimately, it's not just a linear relationship between a top date and the bottom date. So this is one of the reasons that we have so many dates to understand this event, particularly from Northeast India. So here is the replication data set. Blue, we have 2 speleothem going back into this time series. And this replication is done by ISCAM age model using the MATLAB. Of 160 years in KMA record, but we don't see that long drawing in these 2 records. We do see there is some drawing, but we don't see a continuous drawing of 160 years. So here is a big picture, ultimately what we find. Although we, in our paper, we did not talk about getting pluvial, drier conditions or variable conditions. There is a reason behind that. What we are seeing here was a record of 3.7 to 4.5. And in this time window, we see that the climate is very much variable. And we see that the drying trend has been initiated in the record around 4,000. Oh, this means that if you see it in such a short window, we might feel very happy to see that there is a 4.2 event. But if you see this record in the longer term context, so now we are taking this record back into from 2000 to 4.6. So if you see the yellow band right there, the 4.2 is not something really standing out. It's not even crossing the 1 standard deviation down. What we have is more severe droughts after 2.8. So this now again means as a proxy person or a paleo person, what we see in our record, actually we don't see any 4.2. There is no 4.2 event, at least in terms of Indian summer monsoon. That's all. Thank you.
Thank you, Gayatri. And it was very interesting. And if you could just give us a moment, I'll just see if you have any questions on the YouTube chat box.
Yeah, sure.
Yeah. We don't seem to have any question there, so I'll probably ask you one.
Yeah, sure.
Gayatri,
Okay, it could be 2 reasons. Either nobody understood what I said or everything is great.
I also have a question, Ayush.
Yeah, sure.
Gayatri, you can stop your screen presentation now. I think that will be better.
Okay, great.
Yeah, so I'm not a speleothem person, but I've always been, sort of jealous of, how high resolution records these features preserve, and how robust data, is there when you have to reconstruct past. My only concern is whenever we look at speleothem records, especially from Northeast India or from the Himalayas or from Central India, there've been a lot of studies, but there are temporal gaps in the data. So if you try to have a wiggle plot where you have, where you try to have all the data together, you do see some temporal gaps. So how do we interpret those? And, is there a possibility, is it just because we don't have, we have not really investigated many spelothems, or those things are just not recorded in all the features throughout?
Well, pretty good and interesting question, actually. I was expecting that. Thank you very much.
Oh.
So actually what happened, there could be 2 possibilities. First is the dating. Really, you need a very closely and tightly spaced dating. That's a very important part. So this is one of the reasons which makes this speleothem studies a very expensive proxy, because you really need a lot of dates. You can see as just a sample which was 1,000 years time duration, we had 19 dates on that. This could be one of the possibilities. Second thing is this, that yes, in Indian summer monsoon over the Indian subcontinent, there could be some similarities, but there also will be some differences. And these key differences is what we are trying to understand, because this is a dynamic behavior of monsoon. We just cannot have, so that was the key question right in the beginning of my talk. I said that we have to think about the location, and then we have to think what the proxy is seeing. So we have already worked on that a lot, and hopefully we're trying to at least see why there is a temporal difference and why they are similar. So my dynamical paper is coming soon. It's in the review process. So once it is done, maybe you'll have many of the answers. So it's completely the dynamical part without any proxy data. And we just use different models to show that what is the difference and what are the similarities.
Okay, hello, Gayatri.
Yeah.
Can I ask one? Yeah. Just a query, and because I've been working in the Ladakh Himalayas on the lake records, of course, not speleothems. Unluckily, we don't get any there. But there also, the 4.2 event, we don't see a very sharp event there, but the 2.6 at 2600 years before present, we do see a very an arid period, and that too in all the records of the Ladakh range. Like there are these small glacial lakes like the Khardungla, near the Khardungla, all the Las, all the passes there. So we've done a study of about 5 of them, and in all of them at 2.6, 2.8, we see this very arid period. So, and this is like multi-proxy, different proxies. So do you think that in the entire Himalayas, from northeast to the northwest, because your cave record of Mamluk says that there are other droughts younger to the 4.2K event. So do you think there is a synchronity between the northeast and the northwest data, especially in the Himalayas, being geographically same terrain?
Dynamically also, they are very interlinked together. So again, the question how they are linked together dynamically, the paper is coming soon. It's on the way. I expect that paper to be in the fall of this year. So that will give the dynamical answer to this question, how the data from Northeast India is linked over North India. This is one answer. Second is this, that 2.8 event is now as a global, is coming up as a global event. It is really a very sharp event which has been recorded in a lot of proxies, not only over India, but also over different parts of the world. We have a paper coming soon in Science Advance, which is coming on October 16th. So it is from Madagascar. We saw this interval there. We see this interval in Northeast India. The exact timing of this weakening is around 2.7. That's what I have dated so far, because I do the hiatus, but exact timing is 2.7. Then we had a paper in Science Advance from Iraq last year, and there you can see that this event is marked. We have made a stack record of different proxies where this 2.8 event has been visible. So I think, but this has no relation with 4.2. It's completely a different event on its own. Because sometimes, one thing is this, that we have to have, the definition of event is a little bit vague for different people. But in paleoclimate community, what we think is an event is something which should have an abrupt start, and it must have an abrupt ending. Then only we can conclude it as an event. Otherwise, it could be a shift. It could be anything. You can see the transition from drier to the wetter phase or something. So for 4.2, we don't see these kind of features. But for 2.8, we do see that it is abrupt in the start. It's abrupt towards its end.
So even Professor Singhvi has put in a question, and I too wanted to ask you that then why 4.2 should be a global event then? Why have made such a big story out of it?
Yeah, actually, I worked with Professor Harvey Weiss, helped him to pile up a lot of 4.2 records from all over the globe. So I know that there are more than 200 290 or something kind of global proxy talking about 4.2. But actually, when you look onto those lake records were great because that was a time when people really had nothing to do much because they were limited by the facilities, by the sources, by the resources. But in today's world, the new lake records are emerging and then they are showing that there is no 4.2. So in terms of huge paleo community, we don't believe in 4.2 actually. So many people, they have already discarded that 4.2 is not a global event. It's kind of a Westerly's limited event. It took place. So even if you look record from the Chinese record, even in China, you have sometimes you see the wet phase, sometimes you see the dry phase, a kind of a dipole from different records. So yeah, we agree that we don't believe that 4.2 is a global event. Seeing more and more proxy data, even seeing the Mamluk record in the context of last 1,000 years to going back to 10,000 years, we don't see 4.2.
Okay. Ayush, please take it in the other questions. Okay, thanks, Gayatri.
Yeah.
Eye opener.
Oh, there is.
Ayush, your mic is muted. Please unmute it.
Oh, I'm sorry.
Yeah.
I'm sorry. I think there are a couple of more questions, and we do have time, so it would be nice if you could
Yeah, I
answer.
can read one of them. There is. Okay, I'll just go from the first one. What is the reason to choose a cave from northeast India linked to Meghalayan stage? Okay, this is a very debated kind of thought process. It's a debate not between paleoclimate community, it's between the archaeological community, because archaeological and I think the Anthropogene group, it's a very long going debate. So who and how they decided it, it's completely a different story. It has nothing to do with we guys. I mean, our group, we were not the one. And even the authors of this paper, they were not the one who suggested that KMA should be the Meghalayan stage. Basically, this was a group of archaeologists who suggested that this should be the Meghalayan stage. Because if you look into KMA itself, being a stratotype, it does not fulfill the norms of stratotype. According to the stratotype, one of the biggest norm is this, that the sample should have still enough Okay, sorry. I think my connection was lost.
It's okay. Yeah.
Cultural impact of this dryness. See, the dryness, as I said, is could be anything. You have a very tapering in on. I won't say Mamluk Cave now because if you see Kathayat et al. 2018 paper, we don't see the dryness there. We don't see the weakening or an abrupt event right there. But in KMA, it could be possibly because of some diagenesis or some alteration. And as I said, in cave system, many things can make the delta O18 towards a positive end. What is difficult is only the monsoon signal can make the delta O18 get depleted. So the host rock, the duration, it's actually, we call it decorrelation timing. So that means how much the delta O18 is itself being mixed in the host rock and for how long time. So I don't know particularly for KMA what is the decorrelation time, but for our new sample, the decorrelation time is around 4 years. Do you see any lag to this event in extreme speleothem and marine records? It's very hard for us to compare the data set with the marine records, as I said, because of the temporal resolution and the dating uncertainty. If you look into our 2018 paper, and if you pick 2 dates from there, just one at the top and one at the bottom, and then you draw the linear interpolation, you will see the new age model with the linear interpolation. This whole event, whatever the things you are seeing, the pluvial or the dryer, they will shift big time. So when you're talking about a very short duration of event, dating makes a big difference. It's really important how many dates you have and how much robust the data becomes. Any more questions?
I think, there's a question by Sanjeev Kar, and it was left on the YouTube comment section. So there's a lake the question is, the Loktak Lake of Imphal Valley, we do get
Mhm.
continuous deposit from 45K to recent, with dry records from 5.4 to 4.8K. Can there be variation in 4.2K date? And he's asked for your comment.
Yeah, it depends. I'm sorry, Santosh, with whoever asked this question, I'm sorry. I haven't seen this lake record data set. For understanding or giving the right comments, I have to first look into the chronology, that how much the chronology is playing the role. If I can understand the chronology, then I can comment on that. But there is a big event around 4.5, I mean, it's 5.2. So it's not necessary that they both be the same. They could be different as well. So there are a lot of papers talking about 5.2 event.
Thanks. There's another question by Anil Kumar, and he's asking, in most of the lake records shown in the presentation, 5.5 and 6.5 to 7K is dominating. However, during this time, most of the rivers are flooding. So any comments on that one?
It's very hard for me to say because I'm not. Two things. First, I'm not the lake person, so I really don't know in detail how really the interpretation of lake record goes on. And the second thing is this, that that particular lake, we really don't know whether it is recording the regional setup or it is kind of local signal. So the first job is to understand for us to really verify the climatology of that particular region. How we can say that, okay, our lake is regional, then we have to put on the conclusion that this is the reason we say that it is a regional record. And if we say that it is more local, then it's a completely different story, because then we know that something happened locally in that particular domain and related to this lake system.
Right. This question by Rahul Kaushal, and he's asking, you mentioned speleothem data has tendency to shift to more positive delta 18 O value. Please explain why is this so?
Of the fractionation, it temperature definitely, because we are not looking into the fractionation is settled down, or the delta 18 is settled down on the regime fractionation. It's very hard to say that it is a climate signal. So, and when the kinetic fractionation will take place, delta 18 won't become negative. It is going to become more positive.
Right. I think this
so there
takes
will
to
be evaporation. Yeah.
I'm sorry. I think there's a.
So there is a very beautiful book by Basic of Speleothem. People who really want to look into, because there are many factors. I'm just talking about one. So there are many factors, including together talk in more detail on that, how the cave system works.
Right.
Yes.
I think this transitions nicely to Professor Singhvi's question. He's asking, Mickler et al. Talked about kinetic fractionation. Can you link the isotopic record to amount of dryness? Do isotopes respond linearly to dissociation?
No, you have to, if you look into Ashish Sinha's 2015 paper, he has calibrated the Sahia speleothem delta 18 with the modern day observation. We don't have a really relationship with dryness and fractionation. It's not.
Right. There's another question by Feroz Khan. He's asking, is 8.2K event also debatable in global reference?
Not exactly. 8.2 has been reported now from many sites, and I don't know how far it's looking in India, because I have not seen, I have not drilled the oxygen isotopes around that interval so far, so I need time to get to there. So it's not debatable. It's very clear cut that there was an 8.2 event right there.
I think there's another question. I think questions have started to pour in right after your talk. There's a question by Professor Anupama. She's asking, in your forthcoming paper, are you discussing processes driving the monsoon and the related precipitation shifts using models?
Yes, I'm using the models. I'm using simulations. I'm using everything what possible I can do to understand how these proxies. Basically, the core idea of that paper is to understand how to do the interpretation of paleo proxy from the Indian subcontinent and what they represent or what they indicate. So the basic focus will be the speleothem delta 80.
On the same note, if I could ask you, after this talk, would you be able to type the title of your paper so that once it's out, we all know, and we can give it a nice read. Since we've talked so much about the paper, it would be nice if you could share the title.
Once I get the paper, I will share it to Dr. Vinita.
So yeah, that would be nice.
That would be that from there. It's still it will take time. So basically, it's related. It's linked with the tagging simulation, this, that. So it has too many things to go in there. So once it is out, definitely I'll pass it to Dr. Vinita.
Yeah, thank you. I think that's it, and it's timed very nicely. So thank you so much, Gayatri, and it was really interesting, and we had lots of questions, and lots of doubts were cleared. So thank you so much for your time, for your talk, and it was really nice to see you. And
thank you so much. Thank you everyone for listening. Thank you for the questions. It's kind of motivation.
Yeah. And on the same note, so next talk on 12th of October, we have Sushant Naik from NIO Goa, and he'll be speaking on the role of oceans in glacial, interglacial variations in atmospheric carbon dioxide. So I hope to see many of you again online next week at the same time. Thank you. Thank you, Gayatri, once again, and have a good day, everyone. Bye-bye.